So thank you everyone for joining. I know everyone is kind of sleeping now. It's the last session, so I'll keep it light since it's a lighting session. Okay, so as you can see, the topic is breaking the Java stereotype. It's not your dead language anymore. The idea is, last year I was traveling from Zurich to Toronto. There was a guy who sit next to me. So we were discussing about different things, random discussion, politics, religion, all of those things. And then suddenly he asked what I do. So as I said, I'm a Java developer. He was kind of, like he was saying, wait, hold on, how come? I mean, I worked Java for like 15 years back. It was, slow, verbose, and all those stereotypes he was mentioning. So I tried to pretty much, convince him otherwise. But yeah, I think that's kind of misconception, stereotype, still, available in other community. I mean, this is a Java conference. I think you guys already know all of these things. It's not true, but I think it's a discussion that we can have at least. So that's the idea mainly. Although it sounds like I'm preaching to the choir here, because you guys are already convinced, and it's a Java conference. I really should not convince you otherwise, right? So anyway, if you have any questions, please join to this, Slido. I don't know if you will have questions, but yeah, if you have, of course. Anyway, so first question would be, as you can see the question, when was the last time you wrote this? Okay, that sounds nice. So yeah, I mean, I wrote this a few minutes ago. I mean, that's interesting. So that's how it has been for many years until recently it changed. I'll show you how it changed, but I guess you already know. So these are the common stereotype essentially. Boilerplate, verbose, slow. Some people will still hold those stereotypes. So in this session, what I'm gonna try with at least few demo and few code examples that it's not true, because I don't have a lot of time. Otherwise, I could go on each items. So I'll try to at least show you on the improvement language features, and the others, especially there was other presentation of what we already had about other topic like project, Panama, Valhalla, Leiden. Those are really interesting project that's coming. But the key highlight is language is extremely, Java is evolving, and the community is also growing. And the key point is, even though Java is doing a lot of things, but unlike any other programming language, it's doing in an incremental and backward compatible ways. That's really key things. People talks about Python, and I guess when you upgrade one version to another version, what happens? I'm not gonna explain that, but I assume there's some experiences. So in Java's cases, it's really not the case, essentially. So anyway, there are some modern features that I'm gonna, try to showcase. First of all, the first one is the instance method. And then gradually I'll try to show virtual threads, records, pattern matchings, and others if I have times. Anyway, so let's go to this demo first. So this is essentially when we start programming. It is especially difficult when you are going to explain this code snippets to a new programmer. I used to teach at a university for 2 years. So when the first day when they install IDE and try to write something like "Hello World," I have to explain. They will come up with all this question: what is this public? What is this class? And static, also all those things. And it's extremely difficult to explain them. So what we do is, just remember them, memorize them. We'll come back in 3 months. So that's how we have been doing. So essentially, over here, what we want to do is we want to print this line, and everything is essentially a ceremony. So what I'm going to do is I'm going to remove all of this one by one. So let's remove the package as well, because it's hard to explain package at the first hour, right? So let's see if it runs. As you can see, it without package and everything it still ran, right? So what about if I remove the public one? How about we remove static one as well? Maybe I remove this, because most question I got, what is this string args? And it's extremely difficult to explain to the student. So maybe we remove that as well. So let's see if it runs. OK, looks like it still runs. And the next question would be, why I have to print a line, why I have to write this many string? Maybe we can remove those as well. So there is a new class available now, which is called IO. In this IO class, there is a few methods available. One is println, and there is also readline, some static functions, methods that you can use. So yeah, if we try to run this, as you can see, it works. So that's a new thing. It's called instance main method. If a class have this definition, like void mains, it will treat as a main method, and you can run it from there. Or if a file doesn't have anything, just void main, it also works. And also you can define variable over here. For example, int, let's say age 10, right? Now you can access that over here. You can write if block, all of those things. And you can also write functions, do something like that. And you can also write a new method over here, say something. So it will also work. So that's flexible now. So it's a easier way to explain programming to the beginners. So moving on, and the next one. Okay, I'll come back to virtual threads in a minute, but let's go to the next one, which is the record class. It's if you want to represent a basic data structure, I need to do all of those things. String. You have to declare the fields, of course. Then you have to write constructor, and then you have all these getter equals hash code. Pretty much 50 plus lines of code. Although there's tools that IDE can speed them, but with this modern Java, you can just write one line code, which is much expressive and easier and less boilerplate. So there was a stereotype, right? Java is boilerplate. I think we broke that, right? Do you agree with me? There is another one. The next one is essentially a pattern matching. All the modern programming languages, especially Scala and many other programming languages, support pattern matching. Java didn't for a long time. So that's a kind of frustration many developers had. Now we have. So I have a few demo over here for pattern matching that I can show you one by one. So I'll just show a few. So we can do switch operation. We can do like if existence of string, and also we can declare a variable over there, and also we can do AND operation and check the length in one line, and then do something or else. We can do the same thing with the switch operations. So there are many other examples over here that I can do. For example, this one, right? We can do switch. And the switch also return value. That's another example of pattern matching. So yeah, now it's more expressive, more easier, and more less code you have to write. There is another one. If you have multiple, for example, shape is a class, and it has it might have a subclass. So you can do case operation based on the object type. All right, so there is another example over here, which is, so I have this example over here. Let me see if I can show you. So over here, as you can see, I have a class for publications, and it has a few subclass. For example, author. Yeah, all of them extend, except author. All of them other. For example, books and magazines, journal article, they extend the publication. So now we can do switch operation over here like this. We want to extract the summary of those journals. So we can do, if it is a book, then we extract certain value. For example, as over here, another interesting thing you see, for example, in a book, there is an author, right? And we are interested only author name, not others. So we can use underscore over here. That's called unnamed variable. And author is over here is a record, and we can do record deconstruction. So see, we use var. We don't have even specified the type name. So that much expressive we can do over here. And similarly, as you can see in the magazine, we are interested only titles and publications, not the other one. So if we go to the magazine, as you can see over here, we have title, publishers, and issue numbers. And we are not interested on issue numbers, so we can use underscore. So basically, you can do a lot of things with a less number of lines. So it's more expressive that way. All right. So that's how you can use pattern matching on record deconstruction. So we have also text block. We used to we used to write JSON SQLs in this fashion, like the first one, and with the string concatenation, it was really ugly. Now we can use text block like this, which is much easier to read, and it looks nice. And then there is another one which is called control inheritance with seal class. I already showed example, but I didn't explain. The idea is we can control the inheritance. Java has an inheritance built in for a long time, but the problem is it's either you open for inheritance, anyone can extend your class, or you can stop it, like string. You cannot extend a string, right? So that there is nothing in between. Now with the seal class, you can you can have something in between. For example, you are a library developer. You want to use inheritance for your own set of API classes, but you are not going to allow it for others to extend it. How you are going to control that? Currently, with the current Java system, it doesn't have that. But with the seal class, you can do that. So what we're going to do is, you're going to create interface or types, any types, and then you will add permits. And you have to specify this is sealed interface or sealed class. And these classes or articles can only extend. And if you want to create another one, for example, let's say record hello, and if it wants to implement the publications, it will not be able to do it because you have to add the permit over here. If it is your code, you can do it, right? You can just add a hello over here. But if it's a library code that you are a library developer, you can you really cannot add anything over there, right? So that's how it's a control inheritance. Anyway, so moving on. So there is another example over here. So what we're doing is, we have a expression interface, and we have a bunch of records that implements that expression. And it's basically basic expression, right? It's a kind of demo that I wanted to build. You add constant 5 and 20, and then add them. So this same code, if you want to use the earlier version of Java, it will take like 60 lines of code. Now we can do under 20. So that's how much expressive it is now. OK, you can also, let's ignore that because I don't have much time. So there are a few other tools over here. For example, now we have JShells, so you can write code on your terminals. We can single file extension execution. So basically, you can write a script using Java now. And I have been using I've been writing many scripts using Java nowadays, and there are a lot of built-in functions. For example, files.write strings. You can put a bunch, you can put argument of a long string, and you can write in a file. Also, you have HTTP client, which is built in. So a lot of interesting things happening over here. Also, there is evolution of GC pause improved lately. Let me skip that for another time. So the idea is, let's compare with the other programming language, like Java was a modern programming language. Let's say Kotlin. Kotlin is considered a concise programming language, right? So Java is getting there. Go is familiar for Go routine, right? And we have now virtual threads. And with the virtual thread, we have the similar competition now. And there are other programming languages, for example, Rust, but Java comparatively faster and mature. It has mature garbage collection. So the idea is Java is now competitive on productivity and performance and many other areas. So before finishing the slides, what I'm going to do is I'm going to show you a quick demo on virtual threads. That's really I wanted to show. So as you can see, I have in this code over here, it's a simple multi-threaded server. What it does is it creates, in a while loop, we keep on accepting sockets. And whenever a socket connects, we create a platform threads, essentially the traditional threads that we have. So now we'll run it. So it will just stay there. And then I'm going to do a DDoS attack, essentially. So I'm going to create 10,000 sockets and try to run it, try to connect all of them at once. Let's see what happens. So over here, as you can see, after a certain times, it failed. The current traditional platform threads, we don't have as many as we want. It begs one single presentation, but for the demo, I'm going to skip a lot of things. So what I'm going to do is I'm going to stop this and run it again with a one line of change. Over here, I'm going to use op virtual. And I'm going to run it again. And let's do the DDoS attack with 10,000 threads, a 10,000 socket connection. Let's see what happens. It just ran, and all of them were able to connect, and there is no issue. So that means essentially we can create as many virtual threads as we want. There's other aspect of it, but due to because of time, I'm not going to explain all of those things. I have like 2 minutes of time. So there are lots of AI initiatives happening. There are a few talks we had in this conference about all those things. So I'm going to skip those. So the final takeaways essentially is modern Java is very concise, performant, and evolving fast. They say we have like 12,000 Java developers around the globe, so we have a strong ecosystem. And most importantly, the deployments of Java is huge. Most of the top programming company, software company, that they have all these huge server-side applications that deployed. They are in tens of, they're in millions, I would say. So that, and Java will not go away any day soon because of those, massive code base that we have already, and the involvement and the community support that we have. So yeah, I would say the Java that we have now, it's not really our parents' programming language 30 years back. So it's a modern and definitely concise a programming language. So I have like 30 seconds. So I have some resources over here if you want to take a look. These are the places where you can find all these resources. Also, if you are interested in concurrency like virtual threads, you can also go into check this book. You can take a screenshot, and that's all. And this is a little bit about me. And I'm gonna check some questions if you have. But thank you for everyone for joining for this very light sessions. I wish I could do more, but due to time, I'm just try to go lightning fast on each topic. So let's see if we have any questions over here. Can you use virtual threads for CPU-intensive tasks or IO tasks? That's a good question. No, so for CPU-intensive tasks, we are gonna still using the platform threads, the traditional threads that we have. We also call classic threads sometimes. Virtual thread is essentially useful for IO-intensive work. Over here, if virtual threads work on a carrier threads, then what is the benefit of create millions of virtual threads? That's a really good question. The idea is when I/O happens. So let's say I am a user. I'm connecting to a service, and that service depends on other services. For example, microservice, database, and other I/O services, right? So let's say I have initiated a connection, and I need to do certain things. To achieve that work, I need to call another services. So there is a communication happens between one service to another service, and it takes time. So now let's say I have a traditional platform threads, and it initiated the work, right? And meanwhile, it's going to wait until the result comes back. So basically, one thread essentially is waiting for getting some result, and then it will process and then send back. So if you see in our traditional web application, you will see most of the cases, all those threads are waiting for get some I/O result back. So basically, let's say you have 1,000 thread in your applications that working. 80% of the time they're going to be idle. So you are wasting because threads are CPU. Threads are essentially valuable resources, but we're wasting them. So if we create millions of virtual threads and with a limited number of platform threads, those platform threads are always going to work, and the virtual threads can wait somewhere else. When the I/O result get back, virtual thread will get back to the platform threads again to work. So the idea is we are utilizing our CPU, and I/O happens outside of our traditional threads. So that's way it increases the concurrency, and we can utilize as many we can utilize the CPU more, and since we can create a lot of virtual threads, it increases the throughputs overall. Essentially, that's the highlight. Okay, let's see. Could you please return to the slide with the linker example you had? Okay. This one, right? Okay. So this is a new API that's available with our recent latest JDK, which is called Foreign Function and Memory API. The idea is you can easily now call native function like C++ functions. Previously, we used to use JNI. JNI was cumbersome, and you had to do a lot of things. Now it's just plain Java. It's a nice API. You don't have to rely on those cumbersome code. Which version of okay, so this this one, let me show you that. Okay, I'm using the latest one. On my machine, it's running 25. From the 25, it's earlier it was available in 24 and 23 as well, I think, but under preview version. But from 25, it's targeted. It's so it's no longer preview. You can when 25 will be available, you can use this easily. But if you want to use like 24 or 23, you have to use enable preview. The additional flag. Okay, so that's all question I had. Thank you very much again for joining. I know you guys, everyone is kind of feeling sleepy. I'm also. So it was the last session, and hopefully you enjoyed it. Thank you very much.